All right, so if you've ever made the jump from the superstructured world of SQL over to the flexible universe of MongoDB, you have almost certainly slammed into one big question. How in the world do you handle relationships between your data? It's honestly one of the biggest mental shifts for developers, so today we're going to break it all down.
So let's get right to it. In a relational database, everything's neat and tidy, right? You've got your tables, your rows, your columns, and of course foreign keys to link everything together. But in MongoDB's document-based world, well, the rules are just different. The real question is, how do you take all that logic you know and love and make it work here?
Well, it turns out you've got two main roads you can go down. MongoDB gives you a choice between what's called an embedded model, you'll also hear this called a denormalized model, and a normalized model. And trust me, these aren't just fancy technical terms. They represent two totally different philosophies for how to structure your data.
You can really boil this whole thing down to two simple ideas. The embedded model's motto is basically data that's used together stays together, which means keeping all your related info in one spot. The normalized model, on the other hand, is going to feel way more like home if you're coming from the SQL world. It keeps data in separate buckets and links them using references.
Okay, so let's dig into that first approach. This is the one that really feels the most NoSQL, so it's super important to get your head around it. What are we really talking about when we say embedding?
So an embedded model means you literally take related pieces of info and you just nest them right inside a single parent document. So instead of a separate table for student addresses, you put the address directly inside the student document. It's all just one self-contained record.
And the payoff here? It's all about speed. It's incredibly efficient. For a classic one-to-one relationship, like one student having one main address, all that information is in one place. You can grab the entire student record, address and all, with just a single query. That's it.
And what's really cool is how this just naturally scales up for one-to-many relationships. Like, what if a student has a bunch of different addresses? Easy. You just embed that data in an array. The student document would have one field that holds an array of all their address objects. Simple as that.
So, you might be asking, why bother with all this? Two words: speed and safety. With an embedded model, you can get a student and all their addresses in a single trip to the database. No more complex joins. This makes your read operations blazing fast. Plus, and this is a big one, if you need to update a student's info and an address at the same time, you can do it in one single atomic operation. And that, right there, is a massive win for data integrity, because the whole update either works or it doesn't.
But if you're coming from a SQL background, I bet alarm bells are just screaming in your head right now. You're probably thinking, hold on a second. If I have the same publisher's info embedded in like 100 different book documents, isn't that a huge waste of space and an absolute nightmare to update?
And you know what? That's a fantastic point, a really important one. In situations where embedding would cause tons of data duplication and update headaches, it's absolutely the wrong tool for the job. And that's exactly why MongoDB gives us our second option, the normalized model.
This is where the normalized model comes in, and honestly, it works pretty much exactly how you'd think it would. Instead of jamming the full publisher details into every single book document, you just store a reference, like the publisher's ID. This is the direct equivalent of a foreign key in the SQL world. When your app needs those publisher details, it just makes a second quick query to go get them.
I mean, just look at this side by side. The concept is basically the same. In a relational database, your book table has a publisher ID that points over to the publisher table. In MongoDB's normalized model, your book document has a publisher ID field that references the publisher document. The logic underneath it all, identical.
So, when is this the right call? First up, to kill that data duplication we were just talking about. If one publisher has thousands of books, you only want to store their info in one place, right? This model is also perfect for tricky many-to-many relationships, and for modeling big hierarchical datasets where embedding would just create these giant clunky documents that are impossible to manage.
Okay, so this brings us to the million-dollar question, right? We've got these two really powerful but really different models. One is super fast for reads and great for self-contained data. The other stops duplication and is awesome for complex relationships. How on earth do you decide which one is right for your project?
And the answer, really, is this. There is no single better model. The best choice is always pragmatic. It all comes down to how your application actually needs to read and write its data. It's all about your access patterns.
So let's break this down into a simple cheat sheet.
You're going to lean towards the embedded model when your app is doing a lot of reading and you need related data served up together fast. It's also the clear winner for those atomic updates we talked about. On the flip side, you'll want to go with a normalized model when every data duplication is a real risk, or when you're dealing with complex many-to-many relationships or big hierarchies.
So what's the big takeaway here? It's that MongoDB gives you the flexibility to pick the right tool for the specific job. It's not about forcing your data into one rigid box. It's about really understanding the access patterns of your application and then picking the model that serves those patterns in the most efficient way possible. So take a look at your project. What does your data really need?
Hey, if this breakdown helped you connect the dots, do us a favor and hit that like button, share it with a friend, and definitely subscribe for more explainers just like this one. Thanks for watching.